All right, this is lesson 22.1 to 22.6. This is part 3, organic chemistry, part 3. Hopefully this will be the last video. In the packet, remember you're going to work everything in the packet. Now, it's better that you don't do anything until after this lesson and after you study a little bit. And you'll know what I mean. Because the point is, can you name all these compounds or draw these compounds? There's a self-study packet attached to the back of your notes that came from a Zumdahl textbook. It's all kind of grainy photocopy, a really old one. But it works great. I just want you to do the circled items that you see in that study guide. You can just flip through the pages. You might think, why did you give all those pages? Well, that's just another way to learn the lesson as well. As you go through and read them little by little, you'll kind of learn what I'm showing you as well. Now, and I said that maybe I would put some extra credit problems. I don't know. If I look into the book, I could do that later on. All right, that could come later even. It doesn't matter. All right, so here we go. This is the most important lesson, okay? The others I was doing was an intro stuff, and even in the last video I made about 3 or 4 errors of naming stuff, but then I fixed myself in it. But it's kind of good because it shows you the rule, how the ruling works, how you name things. And we'll come back to that in this part. But anyway, you remember, as I said, that you had to memorize polyatomic ions in earlier in the year, phosphate, carbonate, dichromate, hydroxide, all that. Well, you're going to have to memorize these, what's called functional groups in organic chemistry. Now, I'll try and go through all of them right now in this video. Oh, and I noticed another thing, that alkene, and alkyne. And there I'm breaking another chalk piece again. Okay, let's see if I got anything left here. Okay, so here we go. This is going to be kind of fun. And you'll recognize some of these names of chemicals. Oh yeah, in medicines and things like that. Not just medicines, but in technology as well, in industry. All right, so the first group is called an alcohol. Now, an alcohol group, a lot of times we write it, you'll see it written this way on a paper, R with an OH. And what you can imagine is R, once I thought it meant root, the root of the root molecule. Is it methane, ethane, propane, butane, pentane? What is the root? And then what is the attached group is the OH, okay? Or someone said that that's the rest of the molecule. It's kind of a weird thing. You'll see that there's some weird things about this. You can probably make some flashcards on this as well to remember it. But an alcohol is when you have an organic compound with an OH on it. Now you might say, well, OH is hydroxide. Well, it is hydroxide when it's with an ionic compound with a metal. But when you have it in an organic compound, it's an alcohol. Okay, so the most simple alcohol is methanol. And I'm going to put, it's on the paper. So for methanol, I'll draw methane first of all. And they certainly could say any of this, like draw a molecule of methanol. So start with drawing, say if you drew methane is like that. But now I'm going to take away one of these and I'm going to put OH. Now, I want to be a little bit better than just this because we're going to be doing our Lewis dot diagrams later. So you have a bond to an O, then you have an H. Sometimes I'll put the OH in the shortcut form. And also you're going to have some lone pair there. If you did the Lewis dot diagram bonus lessons earlier, then you'll know. If not, we'll be getting that soon into the next semester. We'll be getting that in the next lessons. Okay, that's methanol. Now, I'll just tell you, methyl, if you hear methyl alcohol, that's the common name for that. And we don't use it in chemistry. So it's on chemistry, we're only going to use the official, AP chemistry, only use the official college chemistry naming system. We call that methanol. Okay, the next one says, okay, 2-butanol. So 2-butanol. First of all, hopefully this is getting a little bit easy to you. You'll see, oh, okay. Butanol sounds like what? B-U-T-A-N. What is that? What is the root, you think? Butane. How many carbons in butane? There are 4. I'll go and draw this. C, 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 C. All right. So there's butane. And I'll put H's around everywhere. Everything will have an H except carbon number 2. Remember that 2 means carbon number 2. 1, 2 will have an alcohol group, OH group. So it can have OH on it. Now, I'll do it like that. I mean, if you really be technical, it's a bond there, and you have a lone pair and a lone pair. Yeah, I better do that. I'm sorry. If they ask you to draw this on AP, you must draw it that way, with a bond and a lone pair. If I was doing this, 1, 2, 3, 4, methane, ethane, propane, butane. On number 2, I put a line up and put OH. That's okay for me. Now, that is not going to get you points for AP, but it will at least quickly show you, oh, it's CH3, CH. Okay, well, I'll make it here. So CH3 on the first one, this carbon has 3 H's. Then the next one has an OH group, and of course it has to have one more H. This will have 2 H's. And this will have 3 H's. Again, CH3, CHOH, CH3, CHOH, CH2, CH3. Now, you don't have to be able really to write it that way, but it's not a bad idea. I mean, if you write this, it's pretty much, you're just writing what you see. But one thing you can always do, like if they were to say, just write the formula for that. Like say, write the formula in a combustion. 2-butanol undergoes combustion. 2-butanol plus oxygen gives you, carbon dioxide and water. So what you could do is write this, and then you could quickly just say, okay, it's C, 1, 2, 3, 4. C4, how many H's? 1, 2, 3. Without having to look at this one, I'll draw that one. 1, 2, 3, 4, 5, 6, 7, 8, 9 H's. And then OH. Now, you could say C4H10O if you want, but C4H9OH, is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, and then OH. C4H9OH. That's fine. If you're doing an equation, you can write that down for that compound, for 2-butanol. If you want to write C4H10O, you could, because technically that's still the formula, but that's probably better. That way you see it's an alcohol. So, so it's kind of like a two-way thing. They can ask you to draw the structure, and you would draw that, or they could ask you on an equation to draw it like a reaction, and I would draw it the way I just did a moment ago, the molecular formula. I wouldn't need to draw all this out. Now you could draw all this out and say this plus O2 gives you CO2 and H2O when you burn the alcohol. Okay. All right. So 2-butanol. Now. There's one more on here, and it shows you when you have more than one alcohol, 2,4-pentadiol. I'm going to just go on and do this on the shortcut way. I think you can figure it out. 2,4-pentadiol. Penta sounds like what? 5. 1, 2, 3, 4, 5. And on carbon number 2, and on carbon number 4, 3, 4, you have diol. That would be 2 alcohols. I might have mentioned that to you. Diol, triol, tetraol. I guess we have that. I don't think you have to know much more from that, farther than that. But even so, I don't even think you're going to have to know diol. Okay, but diol would mean there's 2. Okay, so there it is. All right. I was going to tell you something else here. Oh, I know what I'm going to bring up. Okay, so we've learned the first group, the alcohol group. So I can take. I have to use a number system. Anywhere, I have to use a number system. 1, 2, 3, 4, 5, 6, 7, 8. If I have octanol, well, which octanol would it be? If you say 1 octanol, it'd be like putting the OH right there. 1 octanol. And if you just said octanol only and didn't have a number, then you'll always assume it's the first one. Okay, 1 octanol. I don't know if I've seen any official word from AP about that, if they're going to do that to you or not. But it's more of an organic thing. But anyway, for sure, if it were to say 3-octanol, 1, 2, 3, then you put it down here. That would be 3-octanol. Or 1, 2, 3, you could put it right there too. They're both called 3-octanol. Remember, the group has, you rank carbons 1 through 10, number 1 being the highest priority. And your group should always try to have the highest priority number, or the lowest number, if you want to think of that. Number 1, you'll be number 1 on the top 10 list. So it can't be number 1, 2, it can be number 3. It can be number 3, or it could be number 1, 2, 3, 4, 5, 6. So it's better to be number 3 on the list than to be number 6. So you have to go back and forth and see which one gives you the best priority. Lowest number priority. I say lowest, highest. Okay, here's a summary of something before we move on. With all these groups, it's good to know how to name and draw. Like when you're memorizing it, like alcohol is OH. Okay, memorize methanol, like methanol. What is the most simple compound you can make with alcohol. And methanol might be the most simple. For some of them it's not, and we'll see that later. But methanol would be the most basic one you can get. And then skip down to like maybe butanol. If I can draw methanol and butanol and name it, then I'm good. You'll know what I mean. I could draw propanol. You know, we did that earlier. I think we did 2-propanol, or I showed you that earlier. Or, you know, hexanol. I could make 4-hexanol. Is it? Oh no, there's no such thing as 4-hexanol. That would be 2-hexanol. See, in my mind, I still have to jump around, but it's okay. All right. So methanol. Now let's move on. The next group is called aldehyde. Now, what a weird kind of name that is. Aldehyde. Now, aldehyde, if you see on this one, I'm going to put the R group, and it goes to a C, then a double bond to an O. Then it goes to an H. Okay, so, oh boy, if I have to circle them. ROH is alcohol. R, then C, double bond O and H. Now, this is the first one, and it's a little bit strange, but I'll show you. The group is called aldehyde, and this would be, I guess you might call the rest of the molecule. R just stands for the rest of it. The most simple aldehyde you can have is called methanol. Okay, now it's kind of a weird, like, think about methanol. Methane would be methanaldehyde. Well, it would probably be better if they called it methanaldehyde, but they don't. They call it methanol. Right, so methanol, methanol, and on the paper you see that one. Like, why in the world do they want to? We want to just get you, don't we, in this class? Methanol, methanol. Okay, methanol. So I know perchlorate, chlorate, chloride, chloride, chlorate. Just one letter changes from one to another. Oh, we're so evil in chemistry. Methanol, methanol. Okay, I want to say it methanol. I'll try to say methanol, because that way you can really hear the A sound on it. Okay, so methanol. Now here's the deal. It only has one carbon in it, remember? So look at this. Here's the catch to this molecule. It already has a carbon in it. So what that tells me is that R is nothing but an H. So sometimes the R is an H. Now in an alcohol, that can't be true. If I put an H there, what does it become? Oh, it's water. So you can consider water an alcohol. I mean, I guess but it has no carbon in it, so, well, no, it's not. It's not. But some of these, if you see a carbon in the group, in the attached group, then that means you can replace R with an H to get the meth, whatever version of it. Methanol is right there, methanol. Okay? The next one it says to draw is propanol. I told you to do methane and butane, but it's okay, propane too. But we'll do. Maybe I'll do that one too. All right, propanol would look like this. So I've got. Remember how many carbons are in propane means 3 carbons. Okay, so I got 1, 2, 3, just like that. Now put H's on everything else, and that one has 4. So propanol. Now, there's something good about aldehydes, at least, that you'll like, and that is you never have a number in an aldehyde name, because aldehyde is like a terminating group. It can only be at the end of a group. Notice that. C double bond O and H. That carbon can only, it can only go to 1 carbon. That's what I'm trying to say. This can only attach to 1 carbon or just to an H in that case. See, this is like the rest of the molecule, whatever you want to call it that. So aldehyde has no names in them. So if I wanted to do butanol, I would just put 1 more carbon on it. You know, it's not really a big deal. If I wanted to do, well, I'll do it the short version. Butanol would be 1, 2, 3, 4, and then what you could do is here you could draw a double bond to an O, and that's all you have to do. It's kind of a weird way to draw that, but you don't need to draw the H. But it's if you want to put an H there, you could. I mean, it's only to help you anyway. It's a shortcut thing. But if you see that somewhere, you know, on a cave drawing or whatever, I'm just kidding, haha. But if you see it, then that will be butanol. All right, and oh, by the way, propanol. I didn't even write it down in here, but I know it is. I'm pretty sure. Propanol has a common name. It's called formaldehyde. And you've probably heard of that before. It's used, like one thing they use it for, it's used in building materials. It's not good because it's known to cause cancer. And they also use it to preserve animals and stuff, dissection. Well, they're dead animals usually, but they are. But in biology or whatever, they'll take the animal specimens and all, and they'll preserve them in formaldehyde. So anyway, so if you're that, now you know formaldehyde is propanol. But so you don't need to know that for AP formaldehyde. You only need to know propanol, methanol. And like I say, if you can do two of them, you might just take the meth and the bute. Methanol, methane makes methanol, butanol, butane makes butanol. Okay? And notice, if I can draw them and name them, that's all. I don't need any numbers in butanol because it can only be in one place. All right. Okay, let's move on. So we got alcohol, we got aldehyde, and now the amide group. So amide looks like this. It's a carbon. It almost looks like formaldehyde, a C double bond O, but then it goes to an NH2. Now, I'm going to be real specific about it. An N with an H and another H. Well, how do I want to draw it? I guess I'll draw it up and down. And then a lone pair right there. Sorry. That is the amide group. The amide group. Now, so there is what's called methanamide, and I have butanamide. Methane makes methanamide and butanamide. So methane, we just want to have one carbon. So it's kind of like the aldehyde. I can just turn that into an H. So I almost don't want to draw it, but I'll do it. Okay. C double bond O, N, O, O. What am I doing with the O's? Oh, not thinking. Okay. Oh, I didn't put my put my lone pair. My goodness. What a mess here. Okay. All right. Did I do it right? C double bond O, NH2. Yeah. So there it is. That would be methanamide. And keep in mind what's going to happen on AP, what has happened in the past at least, is they'll say, draw below in this box the structure for methanamide. They would say, like, what? Okay, so you would draw that one. You'd have to draw it. And I did not do it very neat. You'll do it better than me, I hope. Okay. And then butanamide, I just picked that one because if you can do the methane and the butane version and name it, then you pretty much can do any of them. Okay. All right. I think it's safer to go with butane. I wanted to show you that last one, propanol, because that's formaldehyde. Okay. So butanamide looks like this: 4 carbons. Well, you can kind of get the idea. And then this last carbon is also a terminating group, so it does not need a number. All right, so a double bond O to N, H, H, and then all these are H's as well. Now, of course, if you had to just write the formula only for this, how would I CH, CHONH2? That's kind of strange. You could write it that way, CHONH2 for methanamide. And some people would think, what in the world is that? And I don't think they're ever going to do that and say, tell me the name of that. No, they've never done that. So they don't go that way around. That's kind of crazy looking. Now, could they draw that and say, what is the correct name for the structure? Multiple choice? Yeah, they could if they give it to you. I don't think they're going to give you the non-bonded form. That would be kind of tough. In fact, there could be an isomer, and you could name an isomer of it. If you know what, remember we talked about that. If you can figure out some other molecule that would come into play there. All right, so now comes the amine group. I guess I'll do one more on this and I'll erase these. Okay, all the A's together. Amine. Now the amine group is one that you've heard of before. And look at the amine. Amine also has NH2 in it. Now I like to draw it this way. I know on the paper, no, I did do it, but I didn't show you the lone pair. I got this from the picture from somewhere else, so that's why. Okay, but that's the group for amine. Basically, you just attach an NH2 to whatever else you have. So now for this one, you will need a Roman numeral, a number in the name, and there is no carbon in it. So yeah, it'll attach. So if I start with methane, and we'll do butane, or what did I put on here? I put methane and propane. I can do either one. Methane. All right, so first let's do with methane. Methane becomes amino methane. You've heard of amino before, haven't you? Amino acid. An amino acid is another group that they've not asked us to have to know that in AP. I guess they think of it more of a biochemistry thing. But it's a C double bond O has an NH2 on it as well. It's a carbon. It has NH2 and, well, anyway, don't worry about that. Don't even worry about that. Okay, but amino methane, I'm going to draw methane. Okay, now I'm going to replace one of the H's with an NH2. I'll do this one because it'll work better. I normally would put it above it, but I'll put an N here, and I'll put a lone pair. So that's called amino methane. Now let's skip ahead, and I said go to butane usually, but why don't I put on here 2-aminopropane. I'll pick that one. So let's do 2-aminopropane. I mean, 2-aminobutane might be better to do that one on each one, 1 and 2. But oh well, it doesn't matter. It doesn't really matter. We'll see if it pops up anywhere. 2-aminopropane. So what you do is this. Propane has 3 carbons. Now, on carbon number 2, you're going to have the amine group. So I'll try to squeeze it up here. Okay, N on the top. Don't forget it has a lone pair, an H, and an H. Okay? So remember that little thing, honk, 1, 2, 3, 4. Nitrogen has to have 3 bonds, 1, 2, 3, and the other one's a lone pair. Okay? And if you don't know about that, we'll just do it for now. Just memorize we're doing it, and when we go over the bonding more or review it, because a lot of you already did it on the lessons. But that would be it, 2-aminopropane. The reason I say to be able to do one of the the methane version, and like I said, the butane or the propane is okay here, is so that way you'll know. Do I need a need a number? I keep calling them Roman numerals. Do I need a number? It's 2-aminopropane. If it was on the first one, it would be a 1-amino. But it's better to go to number 2 because that way you'll know. Is it possible to go to number 2? Some of these cannot be on carbon 2, so you know we don't need a number. But this one did. So there it is. Okay. All right. So we got all the A groups. Hey, we're a fraction of the way through all of this. Now, see, this is why this lesson is so important. Because I'm teaching you all these things right now. And now you got some weeks, hopefully, of time off that you can you copy this down, memorize them. What is an alcohol? What's an organic acid? We'll show you that in a minute. What's a amide? What's an amine? What would that be? Okay, and then you try to name them after you've memorized them. So it's better after this video, it's better that you don't even try to do the worksheet now, but that you wait a while. Or you might do like just the odd ones, or you know even better, maybe you'll try and do them on another piece of paper, but then don't write it on the actual worksheet. Then go back to that same worksheet like in about a week. Don't think about it for a week, but just think about the groups, what are that called, and then try and do it. Don't look at the worksheet again. So you get to memorize it. You got to be able to know all of these. And usually on the AP, I think there's going to be about 9 or 10 of these. We'll see how many there are. But usually on the AP, they're only going to ask you to draw one of them. So which one? You'll find out. Now, there could be other ones in the multiple choice. You know, whenever I say it's on the AP, they always say this and that. I'm usually always talking about the free response, the written section. That's half of your test. In the multiple choice, they don't give out the multiple choice every year, but they give out the written version every year. And so we can look and see that they're doing this over and over again, have you draw an organic structure. There was a year when you had to draw 2 organic structures. I think they drew 2 for you and had you draw 2. So sometimes they could ask you to draw 2 of them. So there were like 4 organic structures some years back, a few years ago. And but again, 2 of them they gave to you, and then the other ones you had to do yourself. Okay, all right. So here we go. Am I doing all right with my? Yeah, I couldn't see my clock there. Sorry about that. Oh yeah, I guess I was getting. Never mind. Okay, carboxylic acid. I'm going to try hard to get through all of it in this video. You can always pause it. Boxylic. Okay, the key word here is acid, an organic acid. Carboxylic acid. Now, what that does is this. A C, in fact, let me let me utilize this little area, the top part of the board. C, double bond to an O, then an O, then an H. And then, of course, there's the rest or the root molecule. There it is. Okay, there's the carboxylic acid. This is a very important one, okay? Probably, I don't know. Like I said, they're all important, but this might be the most important one. All right, so organic acids all have this same group attached to it. Now, the carboxyl, I don't really want to tell you a lot about that because it might confuse you a little bit. But I'll just tell you that whenever you see something with a C double bond O on it, then it's considered some kind of a carboxyl. Well, I don't want to get into that now because you say, well, what about the? Well, because you've seen that already on other groups. Like for example, an amino acid is also has a carboxyl. But let me not even. I've already said enough to mess you up. So I don't want you don't have to know that. That I would know. I haven't heard that any updates that you need to know that. But carboxyl, there's one organic acid group, and there it is. That you need to be familiar with. All right. So meth, and I picked hexanol in here, but maybe I should change them one day. Okay. So for methane, here's what happens. Methane becomes methanoic acid. So the naming always becomes anoic acid. Methanoic acid, ethanoic acid. Propane, propanoic acid. Butane, butanoic acid. Ooh, that smells horrible too. I'll tell you a little bit about that when we get to, well, if we do that one. All right, so methanoic acid only has one carbon. Now look again. This is also a terminating group. That tells me carbon is in it, and it can only go to one other carbon. So this can never have a number in the name. That's a good thing. You're not ever going to have two butanoic or three, whatever. You're not going to have 1, 2, 3, 4 numbers on them. They're all on carbon number 1. So methanoic acid would look like this. C. Oh, it wouldn't even do that. Sorry. Methane has 4 H's. But now, since I have this, really, it's better to say this. Since it has a carbon, just put an H right there. That's what I told you before. So it just has one H attached to it. So then it's double bond O, then O to H. All right, that's called methanoic acid. Now, oh my goodness, I need to draw another one for you because you'll like this. Well, first I'll draw this and I'll quickly erase it. I don't know why I put hexanoic, but oh well. I don't know why. I should have put butanoic instead, but hexanoic acid has 6 carbons in it. I'll just do this. 1, 2, 3, 4, 5, 6. And this last carbon right there has a double bond O. Then it has an OH on it. So there it is. 1, 2, 3, 4, 5, 6. 6 total carbons. The last carbon has a double bond. Or you might call it the first carbon, technically, or whatever you want. How you want to do it. No numbers needed anyway, so it's okay. So that's hexanoic acid. Now, there's something important that happens to hexanoic acid and every acid. And let me do ethanoic acid right here for you. Oh, there's a lot of stuff I'd like to tell you about these acids, but oh well. See, we're going to see this come up in the acid chapter. So ethanoic must have ethane, 2 carbons. So you start off with ethane. Then you have a double bond O. Oh no, I'm going to have to do a little bit better. Then an O and an H. Okay. So now there's something else you need to know about this particular group. An acid. Let's just think about this for a minute. You know that hydrochloric acid is an acid, and you probably know that nitric acid is an acid. I told you the ones that were strong. And when they react in water, what happens is they break up. They dissociate. The H plus comes off, and then Cl is left alone behind. Well, in this one, the H plus comes off, and nitrate is left behind. Okay, well, in an organic acid, you also take off an H, and something else is left behind. And let's just see what that's going to be. In fact, to do that, I guess I'm going to have to get rid of my little hexanoic acid here. To do that, I'm going to take this one. If I take the H off, it becomes C, double bond O. That stays the same. That's the same. That's the same. But now, this O actually has, only the H comes off with no electrons. Bonds are made of electrons, by the way. And you'll see this later on if you don't know it yet. So it leaves a lone pair, and then the H plus comes off. Well, H plus means it's plus 1. Guess what? This is an ion, -1. And here's a word you'd like to hear, a polyatomic ion. So guess what? If you know methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane, if you know all 10 of those, now you're about to know 10 more polyatomic ions. And you have to know them. And you're going to know them right here. Watch this. This is called methanoic acid. This ion is called methanoate. Methanoate. So methanoate ion. I don't want to confuse the H with you. That is called methanoate. I mean, H plus is also going to come off of it, but that's called methanoate. Methanoate ion. All right. So you just need to know that. And if you had to draw, if they were to ask you draw the methanoate ion, you have to draw this, and you have to put brackets around it, and you have to put the charge. Whenever you have an ion, you must put brackets, and you must put the ionic charge outside it. Okay. All right. Ethanoic acid, well, it would make what's called ethanoate. So if you have to draw ethanoate, just think about, you might start with, this first draw ethanoic acid. In fact, I could just, on the chalkboard, I could just get away with it. Well, I'll actually do it, because you have to do it on your paper, I guess. And I'll draw this. Because also, I want to tell you something about this. C double bond O. O. And of course, it's going to have the lone pair there, and there it is. It's a -1 charge. It's always going to be -1. So ethanoate, just take away the H plus and leave that little, if you want to keep the bond there, I mean, you can't do that for your official diagram, but that will just remind you that should turn into 2 dots, okay? Anyway, ethanoate. Now, have you ever seen this anywhere before? What is that? CH3 COO. Have you seen that somewhere before? CH3COO. What about if I rearrange it to just C2, there's 2 carbons, H3O2. Oh, and by the way, it's -1. Yes, you have seen that before. It is called acetate. You're like, wait a minute. Acetate? What is this? Yes, organic has another name for acetate. You can name it acetate, or you can name it ethanoate. So now one of the so actually a moment ago I said you're about to know 10 more polyatomic ions. I was wrong. You're about to know 9 more polyatomic ions, because you already know this one, right? Acetate. So ethanoate is this ion right here. All right. CH3COO -1. And that's generally how we would write it. If I wrote CH3, CH2, CH2, COOH, that would be 1, 2, 3, 4. That would be butanoic acid right there. And then butanoate would be COO -1. Butanoate, 4. And butanoic acid is found in, you have smelled butanoic acid before. If you haven't, I don't know if you want to know this before lunch or after lunch or never. Maybe far from lunch. Don't be near a meal right now. This is gross to you. But it's in Parmesan cheese, for one thing. You notice there's a strong odor in that. It's butanoic acid. Also, if milk goes sour, it's in that as well. And there's another time that you've smelled this, and that is in vomit. Oh, yuck! Okay, so yes, butanoic acid is present in. Isn't that amazing? When I read about that once, I think I didn't want to eat Parmesan cheese for a long time. I love it now. I mean, I love eating it on all kinds of salads, Caesar salad. But boy, when I heard that, I'm like, oh my gosh, the same thing. Oh, go. Okay, all right. Well, anyway, let's move on. Okay, so we got it. So that's a big one for organic acids. Carboxylic acid, or I just call them the organic acid group. Okay. Now, okay, the ester. Now, this is pretty big deal. Do I want to skip ahead for this one? No, I'll just go in order. Okay, we're at a big point right now. This is a pretty complex thing I'm about to show you here. Now, this Um, in organic chemistry, this is really, really a cool type of chemical called an ester. Sometimes I think a couple of times I've had a student in my class named Esther. So isn't that cool? If your name is Esther, you get a group named after you, an organic group. Well, let me see if I can tell you how to think about this. If you ever have any odor, anytime you've had a fruit or a plant with an odor there, that's pretty much always what's called an ester. Esters are what make those odors. And it's not just the odors, it's also the flavor of the fruits are also esters. You can taste them and you can smell them. It's really cool. And there's an amazing lab that we have where you can make esters. And we make them in the classroom and you smell the odor. Like you can smell like banana odor or an apple odor, things like that. It's really amazing. So anyway, they all have their own formulas for them. Well, here is the formula for an ester. You have R, then you have CO, another O, and another R. So sometimes they'll put R, and they'll call that R, and they'll put a little prime mark there. What it means is, in an ester, you join together two different organic compounds. Now, AP used to require this lab. An esterification, they call it. It's an organic chemical reaction. I'll just real quickly throw in here and say one of the pretty much the number one reaction. It's got to be close to number one in 80 years of AP that they ask you to do when they ask you to write a net ion equation. Is they ask you to do a hydrocarbon combustion. Write the equation for the combustion of, let's just say methanol. Okay, methanol. CH3OH plus O2. Well, that's going to give me H2O and CO2. And then you got to balance it and stuff. Or if you can always write it CH4O if you wanted to, but you don't need to do it that way. But it could be methane, ethane, propane, butane, pentane, hexane. It could be any organic compound, and oxygen is going to give you that. I mean, if there were a sulfur in there, then you could also say I'll get SO2. But that's not even been the case. What they pretty much always do is they take a hydrocarbon, and usually it's something like the more basic ones like propane, methane. I think it's usually an alcohol or the basic. It's either methane or methanol, ethane or ethanol, propane or propanol. I think that's usually what you get on those reactions. And that might be the number one most asked kind of reaction on the AP exam in all the years. It's got to be way up there. If it's not, it's got to be way, way up there. I mean, maybe someone would say no, single replacement. Well, I don't want to get into an argument right now. But I'll just tell you, that's a really high one up on the list. Well, here's another one that we kind of wonder, are they ever going to ask you to do this? Because they used to have a lab experiment on it, an esterification, which is a cool lab. But I'm going to show you that reaction right now. Because if you understand this reaction, you'll understand this compound and how to name it. In fact, let's go to the first compound. And the first compound is called propyl ethanoate. Propyl ethanoate. Actually, I'm going to do it backwards. Well, am I going to do it backwards or I guess I will. Propyl ethanoate. I'm going to write it over here. All right. There are two chemicals that you add together to make an ester. And it's going to be always an alcohol plus an organic acid. So we just learned about, if you want to say carboxylic acid. So it takes two things to make an ester reaction. Right? Ester reaction. Now I do want you to know this. It's an alcohol plus an organic acid. Now, when you look at the name, you'll be able to tell what things were put together. And guess what? There's a big hint. Can you see anything here related to an acid? Yes, you see ethanoate. So ethanoate tells me that they used ethanoic acid. Ethanoic acid. And so I'm going to put ethanoic acid right here. We just drew it a moment ago, didn't we? So we'll do it again. CHHCOOH. Oh, I like to draw the acid first. I just realized that. I should have moved it over. Okay, we'll figure this out. Ethanoic acid plus an alcohol. Well, if that's the acid, ethanoic acid formed this compound. Ethanoic acid was combined with propanol. Propane, propanol. Okay, so propanol. So propanol is this, remember, has 3 carbons, and you have an OH. You know what? I'm going to, just to make it work a little bit better, to see it better, I'm going to put the OH over here. The OH there. All right, so H, H, H. So I'm kind of drawing it. If we said draw propanol, probably you would draw it the other way around, you know, like a mirror image of that, or reverse. But it's okay. They're both correct, propanol. All right, 3 carbons, the OH is on. It didn't give you a number. You didn't call it 2-propanol. So yeah, if we just call it propanol, you would assume it's on the first carbon. Okay, so, and you want to make what's called, I'll have to put it down here, propyl ethanoate. Ethanoate. So here's what happens, and it actually is pretty easy to know. You take the organic acid, I don't know if you can read that messiness. Ethanoic acid plus propanol gives you propyl ethanoate and water. So here's what happens. So here you have an OH and here you have an OH. This is going to be where they join together. But think about this for a moment. On the ethanoate, think about only about ethanoic acid. When it becomes ethanoate, what does it lose? It only loses one thing. It only loses a H. Now for a moment, that will be ethanoate right now. And the H comes off. We'll put the H over here. Well, if I told you that water comes off in this reaction, guess where the water is H2O or HOH. Guess where the OH comes from? Yes, it comes from the alcohol. So back to, if I want to draw it really quickly, this H, all of that right there is water, and it comes off, and then this becomes attached to that right there. That is the molecule. So where the O used to go to an H, the H joins, really the H is going to join on to a lone pair. The H is going to be pulled off by this OH and to make water. And then as a result, you're going to get the propyl ethanoate. In fact, let me just draw it down here. So propyl ethanoate, what you do, if you're asked to draw propyl ethanoate on the AP exam in this box, always draw it backwards. First draw the ethanoate, like I did. And in fact, it might end up being, the whole thing might end up being backwards. If you want to, I'll just draw the whole thing. I'll call it backwards. Now, propyl ethanoate. So first I'm going to draw ethanoate. I'm sorry. I did bad. First I'm going to draw only ethanoate. I was starting to draw the whole thing there. All right. Ethanoate would have a C double bond O and another O right there. Remember? Now, of course, it would have that. But okay. But ethanoate looks like this. But now this is going to be attached to propane, propyl. Carbon, 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 and of course it brings along its H's. And there is your ester. So this has got to be the most complicated one that you have to know for AP to draw. Propyl ethanoate. Now, because it's tough, I think it's better to go on and memorize the reaction, because the reaction actually tells you what's going on. Ethanoate was ethanoic acid, and then the alcohol was propanol. So then take the H off the acid, the OH off the propanol, and then just put those two together. That bond goes to the carbon now, and there it is. Now, if they show you one drawn, like in fact, I also drew next to it ethyl propanoate. That also exists. But I'll say something about that in a minute. If you see a molecule now and you got to name it, always look for the acid part of it and say, okay, that's the acid part, the OH part, this part. So which one is that? 1, 2 carbons, methane, ethane. So it's ethanoate, and then what is it ethanoate attached to? CCC, carbon, 3 carbons is propyl. So ethanoate propyl, that means it's propyl ethanoate. So you draw it backwards and you name it. Now, if you want to really be just super, flip it around the other way, then they'll be like, the AP grade will be like, wow, this guy or this girl, wow, look at this. They really drew it propyl ethanoate. They drew it. Don't mess with that. I mean, because I'm afraid if you try and do that, you're going to leave off a carbon or an H or something. But okay, all right. So there is such thing as ethyl propanoate, and I'll just draw the stick diagram of that about that one. So if I want to draw ethyl propanoate, first I'm going to draw propanoate. Methane, ethane, propane, and of course that goes double bond O, and then another O, and it will go to an H. That's a carbon right there, okay? So methane, ethane, propanoate, and then ethyl means I'm going to put on an ethane. So it'll go to like that, a carbon, methane, ethane. So carbon, carbon there, that's ethanol, ethyl, and then that's methane, ethane, propanoate. Well, if you want to throw in the carbons, carbon, carbon, and then you can put H's around everything else. But there, anyway, that's how it will go. Not a big deal for that one. But should I draw that? Well, I kind of drew it. Let's just do it quick. I don't know if you can see it down here. Oh no! You can see. Listen, you can see this part. My ridiculous drawing. Well, okay, I'll put it up here above. I'm like, okay, draw it, fella. Ethyl propanoate. So first draw propanoate. Carbon, carbon, carbon. I'll put it here. And remember, on propanoate, you've got this. If you know this already, you can jump ahead to the next one if you want to flip it ahead. But because some of you might want to see this. Okay. Oh, I might have left that off on some. No, I didn't. Okay. Now that's propanoate. Now ethyl just means two carbons. So H, 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 H. So yes, there it is. Okay. So that's propyl ethanoate. No, I'm sorry. Ethyl propanoate. That's ethyl propanoate. That's propyl ethanoate. So the O8 part always goes with the carbon chain that has a C double bond O on it. The carbon chain with the C double bond O, that's the O8. Methane, ethane, propanoate, ethyl. Ethyl propanoate. This one, the C double bond O is on the methane, ethane. On the 2 carbon chain, so it's ethanoate. 1, 2, 3, propyl ethanoate. Okay, all right, wow. So now the good news is we just did 2 tough ones, and organic acid's not real hard. Ester is very complicated. But now the ones left are pretty easy. So here we go. On the next page, after ester, comes something called ether. You say, wait a minute, ester, now ether, are you trying to mess with me? What is this? Okay, ether, ester, okay. An ether is very interesting. This is going to be, it's going to look a little bit similar. It looks like this, actually. It's a little bit similar to what we saw in esterification. You're going to take 2 other organic groups and join them together to make an ether. But what I'll do here is I'll show you, I'm going to show you, let me see, I'll just show you to take the 2 groups. I'm not going to go into a reaction for this one. The first one says methoxymethane. So, like what in the world? Methoxymethane. You could join 2 methane groups together. A methane and methane can come together to make methoxymethane. So what you do is, it's just like it would say, draw methane, then you put an oxygen, then another methane. Now, there's a common name for this that you don't have to know, so you can plug your ears up. It's called dimethyl ether. Dimethyl ether. That's one of those tongue twisters. Dimethyl ether? Dimethyl ether? Okay, so that's an important one in medicine. I believe they use it as well. So, but anyway, methoxymethane. And the other one says, let's do propoxyoctane. And what happens is, when you're naming these, propoxyoctane, you always put the longer chain gets to keep the name the same way. So if you put together propane and octane, octane's longer, so it gets to stay octane. And propane is the one that becomes the prefix, propoxyoctane. If I put together ethane and butane, it will be ethoxybutane. Okay, so the long chain stays as that was. So propoxyoctane. So propoxyoctane. So if you want to do the same way, well, I could do either one. Do that one first, do the other first. So propoxyoctane. This is a lot to draw, but I guess I can do it here quickly. Oh no. It's going to be hard to do that. 1, 2, 3, 4, 5, 6, 7, 8 to fit it on the board. In fact, I'm going to have to cheat a little bit. Not really cheat, but I'll do this. Okay, so 1, 2, 3, 4, 5, 6, 7, 8 carbons, 3 carbons, propane, oxyoctane. So propoxyoctane. There it is. And then just put H's on all of these. It's definitely good to know the shortcut method for the. I don't want to go through and write all these H's. And you don't want to see me draw them. But if you had to draw, I don't think they're going to ask you to draw one this long. But if they did, don't forget to put your lone pairs right there for the oxygen. The 2 dots above it and 2 dots below it. Messy, but they're all there. Okay, and so it's easier. Methane, ethane, propane, oxygen there in between those two. Then 1, 2, 3, 4, 5, 6, 7, 8. 8 to O. 1, 2, 3. Propoxyoctane. There's the little short version of that one. Okay. And now we are getting there, you guys. We're getting there. We're almost done. I'm going to have to just erase all this. The next one you'll like a lot because you already learned it. It's called the hydrocarbon. I tried to say it earlier today. I'm like, what in the world? Hydrocarbons. And what those are is you have an R and then you just have a halogen. So the halogen, the letter X is used a lot of times to represent. It can represent fluorine, chlorine, bromine, or iodine. And these are easy to do. This is one of the first ones I showed you. So, in fact, I jumped straight ahead to do dichloromethane. I'll tell you what, first I'll do chloromethane. If I did chloromethane, then I put a carbon, I draw methane, and instead of having 4 H's on it, I have to put a chlorine there. Now, when you put a chlorine, and this is a little bit more advanced if you haven't had it yet, it also has to have lone pair around it. So that would be chloromethane. So if I want to do dichloromethane, I'm just going to put another chlorine wherever I want. And you can put it anywhere. You can put it anywhere you want. And I won't show you in the model sets, but if you built this, it doesn't matter where you put it. You always build the same thing. It's kind of weird to imagine that, but it's true. But when you put these two, when you look at the shape of it, even if you put them across, you think they're across from each other in the diagram, but in the actual molecule, they're related. They're relative to each other, exactly the same. It'll look exactly the same. I'm telling you, everybody that builds that molecule correctly, if you draw, you can draw it any way you want on the paper. Okay, and it will be built correctly regardless. Okay, and then there's one that says 2-dibromo 3-chloropentane. 2-dibromo 3-chloro. 3-chloro what? 3-chloropentane. I was forgetting. Okay. All right. So first, I'm going to draw pentane, which is, I guess I'll draw the whole thing this time. Now I'll do the shortcut up here. 1, 2, 3, 4, 5. You're going to have di means 2 bromines on carbon number 2. 1, 2. So this one's going to have. I'm going to put BR on carbon number 2. Carbon 1, 2, 3, 4, 5. Carbon number 3, I'm going to have just 1 chlorine. 1, 2, 3. I'll put a little Cl right there. So that's going to be it. That kind of, I'm mapping it out there. So the first carbon has to have 2 bromines on it. And it doesn't matter where you put them. I can put it there, or I can put one on the top and one on the bottom. Okay, I can do it. It doesn't matter. It does not matter. It does not matter. It does not matter. Always the halogens will have dots. In fact, if you want to, you can, when you memorize, oh, not on that side. When you memorize the little whatever structure, you put dots around it if you want to. If that'll help you to remember. What did I do? Vela put an FL? Okay, my goodness. I was saying it and gosh, boy, the things that I can do. Okay, all right, so here, the mistakes I can make there. I know y'all were yelling at me like, Vela, it's not FL. That's like the first most basic quiz. Okay, so, all right, those are H's. And then on number 3, 1, 2. Oh no. Well, you know what? That's why I tell you it's good if I make a mistake. 2-dibromo. They have to be on carbon number 2, not carbon number 1. So what I can do, because I want to just, I have a chalkboard, I can do this. The bromines have to be on carbon number 2, so they have to be above and below each other. 2-dibromo. And then number 3 is going to have a chlorine. And it doesn't matter where the chlorine goes. It could be on the top or on the bottom. 1, 2, 3, 4. And you need one more carbon, 5. And these will be H's. Let me double check this and make sure I did it right. Okay. So, 2-dibromo. Carbon 1, 2, 3, 4, 5. Pentane has 5 carbons. Carbon number 2 has 2 bromines, dibromo. And carbon number 3 has 1 chlorine. Yeah, that would be correct. Okay. And again, remember, you name them. If you have more than one group, and that would include, like, if you had an amino group, an amino and a halogen group on it at the same time. But you would always look, you put them in alphabetical order. Bromo comes before chloro. So bromo comes before chloro. You ignore the mono, di, tri, tetra part in the alphabetical order. Bromo before chloro. Now, the other rule is for the numbers, the bigger group, the one that is a larger molar mass, and bromine is larger than chlorine, it needs to have the lower priority number. So it's going to be called 2-dibromo and 3 for chloro. Okay, because chloro is smaller. You wouldn't do it backwards and say 1, 2, 3. You wouldn't call it 1, 2, 3, 3 chloro, 4-dibromo. You wouldn't do that because then you'd be putting the big molar mass compound. Bromines, you'd be putting at priority number 4, and they should be a higher list on the top 10 list or whatever. Okay, all right. So that's the hydrocarbons, and what's left? We have only the ketone left, and then there's one little thing I'll just mention. Ketone. Now, ketone. This is a group that looks like this. It's like, what? No, another double bond O? But then they have 2 R's attached to each other. R. So 2 different R's attached together. Now, what's strange is in the ketone, you see that the C is going to be part of one of the groups. A C double bond O and another carbon. That'll be a carbon and that'll be a carbon right there. They cannot be H's. They have to both be carbons. There has to be 2 different organic groups. So the first one is called propanone. Propanone. Now, it's called propanone, and what happens is, you know what? I better do the other one first. 3-heptanone. Then we'll come back to that one. I want to explain this first. 3-heptanone. So I'm going to draw a heptanone. That's like heptane. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. On carbon number 3, that's where you have your double bond to the O. So carbon 1, 2, 3. I picked that weird one down here. That's where your double bond to the O will be. So you name you name it, even though there's 2 groups that came together to form it, you name it as one long continuous chain, and you give a number as to where the double bond to the O is. So 3-heptanone, that would be it. I really don't want to draw that. CH3, CH2, CHO. Well, I guess I'll do it that way for you. CH3, CH2, CHO, CH2, another CH2, and then, CH3, CH2, CHO, CH2, CH2, CH2 again, CH3. There it is, 3-heptanone. Propanone would look like this, methane, ethane, propane. Now, you don't have to use a number on propanone. That's why I didn't want to do propanone first, because you have to put a number as to where it goes. Because a double bond to O can only go in one place on propanone. It has to be there. So there is no number. I think I have one on my notes and I scribbled it out. But there can be no number in propanone. C double bond O. Because there has to be a carbon on each side of the carbon that's attached there. So there has to be a carbon there and a carbon there. So then, of course, then there'll be H's all around these. And there. And And that carbon doesn't need an H because it has 1, 2, 3, 4 bonds already. All right. And then I'll show you. I know we're already getting to our time. Now, I have shown you all the groups. So I don't remember how many there were. If there were 9 or 10 groups. There's also what we call the alkyl groups. Alkyl. But you know what? We did that in the very beginning. We don't need to do that again. But alkyl groups would be like methyl, ethyl, propyl, butyl, pentyl, and that kind of thing. Like if I have pentane, 1, 2, 3, 4, 5, and I put a little line right there, remember that would be called 1, 2, 3, 4, 5 pentane. And that will be called 2-methyl pentane. So methyl would be the group. So methyl is like, C. Start with methane and take away that. That's the methyl group. Draw ethane, take away an H, that's ethyl group. In fact, I'm going to say something about that. Ethane, that's ethane. But then an ethyl group would be just take away that H. So now if I stick that onto somewhere, like if I put here, I can do it that way. Well, no, I can't do it that. I think I did that earlier and got in trouble on my last video. I drew it wrong. But if I put a carbon there and then there, if I could CH2, CH3 there, I could have 2-ethyl pentane. You could draw that. No, 3-ethyl pentane. I would put my little ethyl group, attach it to the middle carbon. A carbon. To this middle carbon on pentane, I'll put another carbon, CH3, CH2, CH3. Okay, but let me tell you one more thing real quick. A bonus. Like, what? I don't want to hear this. Okay. Well, because lately they have asked about this. So ethane looks like this. Now, remember ethene? There's something special about ethene. It's another kind of group I'll tell you about. Ethene looks like this. C, double bond to C. Then you have an H here, an H there, an H there, and an H there. Well, it turns out, if you take away an H from that, this is called ethenyl. E-F-E-N-Y-L. Ethenyl. And the common name for that is actually called vinyl. And you've heard of vinyl before, like plastics. Okay, so vinyl. But anyway, ethenyl is the group that you could say. So for example, if I had if I put a chlorine right there, well, the way you would name that would be chloroethene. Chloroethene. But the common name for that, and you don't really need to know the common name, is called vinyl chloride. Now, they have used the word vinyl on the AP to explain something before on an organic problem. And I just wanted you to be aware of that. That's why it was just a few years back. But chloroethene would actually be, the common name is called vinyl chloride. Vinyl is the ethenyl group attached. You take off that and you attach it to whatever. Okay, well here's the deal. This group can repeat over and over again. It's called, it forms what's called polymer. A polymer. So like this one, well actually what can happen is, let's start with ethene for a minute. This ethene can break off, and now that bond can come around, and that bond can come around to another ethene, okay? And then that bond can go off and on and on into a chain. And so what they do is they'll put a little group around that, and sometimes you'll see a little N written down below it, and that's called a polymer. And so what it means, it's a repeating pattern over and over again. This makes chain to chain to chain to chain. Well, have you heard of PVC? Like if you ever go to Home Depot, PVC pipe. Give me some PVC pipe. Polyvinyl chloride piping. All right, PVC pipe. Well, that's what it has. Is it has the it has this. This is the group that how do you say, repeats over and over. Like I break that off and I put that onto another one over here. So I take a bunch of vinyl chlorides. Okay, I put a bunch of vinyl chlorides and they react them. So the double bond breaks and one goes to one vinyl chloride over here, one goes to one there, and on and on and on. It makes a chain, and it's a really strong material. So anyway, that's what PVC is. I just thought you might like to know. Okay, so we have done all of these, and yep. And then there's a little summary on the next page. It just told you all the groups. alcohol, aldehyde, alkyl group. I threw that one in there. That's like methyl, ethyl, propyl, butyl. Then we have the amide, the amines, the carboxylic acids, the ester, the ether, hydrocarbons, and then the ketone. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups if you count the alkyl groups. And then I showed you the vinyl. I don't think you're going to be asked to draw the vinyl, but they've asked something about it before. That's why I want to bring it up. Well, anyway, that's it. So now you just study those and be able to know how to name the compounds. And then maybe if we ever get to see in person, we'll build these as well in a lab, an organic set. It's fun to do. All right, I'll see you guys later on. So study this and maybe wait some time. Just do a few a day. Every couple of days, just say, kind of learn one or two groups a day and how to draw them and stuff. And how do you name the methane version of it? And let's just say like the butane version of it. How do you draw and name the methane, like methanol and butanol, okay? Or aminomethane or 2-aminobutane, whatever like that. Okay, I'll see you later.